So yes, good evening all. My name is Remy. I've been working as a front-end architect, and I've been developing their new Flutter mobile application, which will be replacing their existing version 1. And actually quite funny, which is not part of my prepared script. Like Christine, I also come from many years of working in React, so Flutter can change. So as those of you who've already begun working with Flutter may know, one of the bigger challenges with the Flutter code base is testing. Currently, the documentation on that topic is a little dismal, with examples covering only some of the most basic use cases. Working on this application at Wyzetalk, we have gone far beyond what can easily be found in a Google search or even a lot of Google searches. To ability, we built the application following a domain-driven approach using block as state management, as well as dependency injection using getit. The strong focus on testing has also had to influence our choice of external packages, as some have been easier to integrate with testing than others. Oh, good, that did change. Our first production-ready version, our MVP basically, is currently sitting at just over 12,300 lines of testable code, probably quite a few thousand more hanging around in our generated files. But I exclude all of those from our coverage report, and this leaves us with a very nice 83% test coverage, which is still increasing and has most certainly not been without more than its fair share of challenges. Today, I'm going to go through two of those challenges and go through a bit of how we dealt with them. As a white-labeled international and localized product, one of the initial challenges we faced early on was being able to run our tests with localization in place. As users can change their language, one of the simplest ways to be able to test the available language switcher was just to expect to find text in their selected languages. Occasionally, we would also run into scenarios where the UIs were unable to be tested as a result of localization dependency that was not available in the context. For localizing the application, we chose the Easy Localization plugin, in part as it supported both local and remote data sources, and the remote came in very handy during the initial development phase. Later, we updated that to use a local source, which we can just push updates through OTA. Easy localization works with simple path notation, which is how the plugin for our other applications works, and that keeps things nice and consistent. Being localization, it is one of the few things that we actually have to set up in the main.dart file. So bringing that logic into the testing space took a fair amount of thinking, and as usual, the resulting code is quite disproportionate to that. Here we have the helper function that I created, which allows, among other things, us to wrap each of our widgets that we are testing with the easy localization provider widget, which in turn gives the test instance access to the locally available mock JSON files for our local data. Which slide is it? Yeah, you can actually just see some of the initial setup that we have for being able to access the mock data. So we have that test mock storage variable, and that is being derived by actually getting the current directory path from the file system and just combining that with the relative path for the fixtures. So that changes one thing slightly when actually running your Flutter tests. In order for this to actually work, you do need to actually suffix the Flutter test command with your folder, which by default is actually just called test. So we run Flutter test test. This isn't the only place where we've needed to actually access mock files within our test. So just having access to this within our text context and defining that actually has just been very useful in other scenarios. Now, I'd like to move on to a more creative test implementation that I've had to set up, something far less likely to be run into in the wild, but I felt it spoke to the capabilities of being a bit more creative when approaching more complex or unusual testing scenarios in your application. I'd hope that none of you end up running into a scenario quite like this. It really is very much something edge case, born from a very specific business requirement. And a few days later, I did actually find a implementation that I am happier with, just a better way to manage the UI logic. But being able to actually test this unusual use case with a test that I could actually be quite confident in with, I was actually quite happy. So I'm not one of those who believes in writing tests for the sake of writing tests. While coverage is a nice measurement for the overall, tests do need to be written for the purpose of testing the business and UI logic before worrying about whether all the lines have actually been hit. It's just a very nice way to sanity check and just confirm that you have actually hit all your logic that you have written. As creative and possibly out there as this test may be, generally does work and can easily be made to fail with an invalid expectation. But before I show you the test that was written, I just want to go through a little bit of the background behind the UI logic that I actually needed to test. There's a reasonable level of flexibility in our application, and with that comes the need to be able to render raw HTML, something Flutter doesn't technically support within their native applications. So to work around this, we actually implemented the in-app browser within the application to render the HTML portions and maintain the backwards compatibility with some of the existing API responses. Some of the API responses that we actually do get can include hyperlinks. And because the existing application is an Ionic, those quite literally just work. Whereas with Flutter, we had to write a custom URL launcher that actually just delegates how these links actually work, because based on what the link actually is, we either navigate to a different page within the navigation tree, or even switch tabs within the page viewer. At this point, the app is still in an MVP phase, so not all of our current features have been implemented into the Flutter app as of yet. Added to that, not all devices may support certain URL schemas. So in order to maintain a quality user experience, we want to be able to inform the user if something is not yet supported, and to maintain consistency. We want to be able to display the same snack bar that is used throughout the rest of the application. The first implementation of this error handling involved returning the snack bar directly from the utility class, which can be seen on the current slide. While testing a class or widget is quite straightforward, mixing the two creates a different set of complications. And I would definitely put this in the if all else fails category of things to do. However, I was still actually able to write a proper test to cover this scenario. So here we have the full test, which may not be easily visible on the screen right now, as there is a fair amount of code to try and showcase in one slide. So I'm going to break this down into smaller chunks, but the one thing to actually just take away at this point in time, that instead of using a test, even though we are testing the class, we are using the test widget, because in the end of this, we actually need to run, because our ultimate expectation is for a UI change to happen. So after we've set up the variables for the test, there is a small helper that I created within the test, which tests as I was running into a bit of race conditions with the UI logic. So there's a short delay that was actually added before calling the utilities class function. And in order for that utility function to actually work correctly and for the snack bar to render, I needed to use a real build code context. We couldn't provide a mock build context into this class. So as with all our widgets, we start with the provide localized widget for testing helper that we set up as part of the localization. And then in that, we actually just call a layout builder, and the layout builder actually provides us with a real build context to use to actually pass to that utility function that we are calling. So many of you may know the most common way to execute a future inside of a widget is to use the future builder. So we've actually got one of those sitting inside the layout builder, and that is what ultimately executes the utility function. And it's set up very simply because in the context of a test, we're not really worried about the states. We're not error handling in the specific test case. So we just listen for the done for the flow to work properly, and we just return a size box dot shrink, because that doesn't actually impact what we return, doesn't really impact what we're testing. So this to date has definitely been the most unusual way I've had to write a test, but stitching this all together allows us to have executed both the utility class, business logic, and verify that the localized snack bar is being rendered to the UI. As the specific scenario we're testing right now with the podcast feature, tapping on that link, that one doesn't work yet. So we are actually throwing out the error at this point. From there on, it's pretty straightforward. We set within the normal flow of pumping the widget, set up the layout builder, one more pump with that 1 second delay just to manage that future builder properly. And then we just complete that off by expecting the flush bar to be rendered, which is just a much nicer and more capable snack bar for those who haven't run into that plugin just yet. And that covers the two extremes of testing that we've implemented over the last few months, maybe a year or so. And I hope that the useful cases and the extreme cases give you a better understanding of what's actually possible with testing in Flutter. And now I'm nervous as hell. That was freaky.
Thank you, Reme. That was awesome. So no, that was I'm duly impressed because so as I'll mention in the next segment, I've written a little toy up for myself and also and tried, like, you know, of course I want to add tests. I know tests are good. How hard can it be? And went through some of the journey that you went. I mean, that's how I usually get myself into trouble. It can be very hard depending on what you want to test. But for example, I also really had the language toggle thing and went through the exact same experience, except that my solution looks a ton more messy than yours. So I learned something, and I will copy some of your code.
I'm pretty sure that was quite iterative, because I think, in all honesty, we probably built the application like 3 times over. Just, you know, especially coming from a React environment, the approach was completely different. And like 3-4 months later, once you actually know what Flutter does, you're like, wait, now I can do this properly now.
It's an interesting point, and I kind of heard it through the line in Christine's talk as well, and I went through the same experience. I came from an Android background, and you know, you start reading about Flutter and it all sounds really easy and okay, everything is a widget, fine, but it is really a mind shift that takes a little bit to get used to and requires a few iterations before, you know, your app will be running fairly quickly, but it will get beautiful only over time as you get more comfortable, I think, with the new programming paradigm. At least that's my experience. And it seems like you've gone through a similar journey.
And I'm pretty sure the guys on my team believe I don't write Dart, I write black magic.
How do you feel about golden tests?
Sorry?
How do you feel about golden tests? Are you using them at all?
I started with those briefly. There was a reason why I didn't carry on with them. I can't remember why. I think it's got very much to do with the fact that our application is very dynamic. So it's complicated enough as it is to try and mock the data for our controlled use cases. I think we had a bit more trouble just keeping everything in line with the golden test. And honestly, the one thing I'd love that React did that Flutter really needs to steal from them is the ability to shallow mount widgets for testing, because the mocking just gets extreme.
All right, I'm asking about golden tests because I started using them a lot, but I think I'm not using them in the way they're intended. I'm just working with a toy app. I don't have a design team in the back. I'm not a designer myself. So coming up with a layout that looks pretty is really hard work for me, and especially if it's supposed to work on multiple screens. So I found myself misusing golden tests and basically setting up golden tests for all common screen sizes that I'm expecting. And then making a design change, running the tests again, and quickly looking through all the changes and kind of, okay, it looks good on all screens.
Actually, no, I do remember why we didn't use golden tests, and it's something they popped in, that they included in the documentation. It was actually logged as a bug as well, but then closed because apparently it's intended behavior. So the golden tests are actually generated against the environment that you're running on, and because we're working on a Mac and our pipelines deploy using Linux, the tests are guaranteed to fail because of a different operating system.
Oh, I see. That makes sense.
That's why we didn't use it. So I think
reason.
Code Magic did actually put together a blog post giving you detailed instructions on how to actually set up golden tests, but there was some extra deploy steps that you had to go through to actually make them work on the deployed environment. Otherwise, ultimately, you need to set up your deployment pipelines on a Mac environment. Which at least as for my deployment pipeline, yes, we do that. But for our automated testing pipeline against code reviews and stuff, Linux machines are just cheaper.
That makes sense. I see there are 2 questions for you from Adrian. One, he's asking about pump. Pump is a synonym for inflate.
Okay.
I guess that's the question. I guess I would say yes, it is. It's, I don't know how.
Inflate is a term they use in a different testing framework.
Yeah, I think pump is simply the keyword for the Flutter. It's so nothing that I came up with. It's just there.
Yeah, no. So I suppose maybe just to explain it a bit for him, just in case he's not. Maybe it covers the question. Is so pumping is just basically it's Flutter's way of moving past the next animation to the next drawn keyframe. So you've got pump and settle. So the and settle version waits literally for every animation to complete. So it's something that you can't use if your testing widget has something like a loading spinner, which has an infinite animation loop. Whereas pump obviously just steps forward to the next keyframe. So in this specific case, it was actually just stepping from the layout builder through the future builder, and it actually just created that 1 second delay for that function to then complete running and get to that next UI step, at which point you'd find the snack bar. If you actually if you did the expectation before that pump, the test would fail because the UI hasn't actually drawn to that point yet.
And also, so I know Adrian is an Android developer. So what is really key to Flutter is that you have kind of constant redraw of the widgets, and that's basically what pump helps you simulate in a test. There's another question also from Adrian, which is more kind of high-level philosophy. What has been your approach to separating your concerns in the Flutter app's architecture?
Yeah, that's domain-driven design. So we did a lot of research into that after our initial version of the app, when we went actually just with completely effectively stateless. We only used these stateful widgets available in Flutter, and that proved to be not a wise decision. So we did a lot of research, and actually a lot of the information we got came from Reso Coder's tutorials on the block and the domain-driven architecture, which that in itself was something that I was actually quite familiar with, coming from the front-end background. We have those architectures in place. But it really is just that separation of your contract layers and your data layers, just to keep everything isolated. And it actually just does make things, it does bloat out the code a bit, but it does actually also increase some of the testing. Obviously there's more things to test, but it's a bit more focused.
All right. There are no more questions at this point. So everybody think about what else you want to ask Reme, and then we'll have you back again at the end of the next talk.
Cool.
All right.